Let's consider our last example in a slightly different way. So you'll see here that I have three different quote-unquote versions of the same polynomial. Here on the first line, we have our polynomial that we started with as the function that we uncovered. We had our three roots, -1, 2, and 6. We multiplied it by -4. We had this look, and we could trace and we could see all of those different intersection points. And I have this scaled in such a way that you could see the y-intercept down here at -48. That was the function that we were working with, and we could even look at a table of values for that function. So as you put in each of the individual x values, what would the y output be? And you can see, because this function is cubic, there's a lot of large constants in front of the individual x squareds and x, that there's a lot of growth happening in this particular function. So in order to see it, I had to scale out the graph a little bit. Now I'd like to introduce two more functions for us to investigate. The first one that we're going to look at is, what if I didn't multiply by -4 at all? So we remember that the negative was there to change the end behavior and face the graph the other direction. And then the 4 was there to scale it so that we actually had the intercept at the right place at the -12, or excuse me, at the -48, instead of being at the 12. So we're going to turn this one back on, and we're going to graph it. We'll see if anything interesting happens. You should see that it's obviously going the other direction because it doesn't have those negatives. But most interestingly to me is that we get these same intercepts. So we have this intercept that's here at 2, and then we're going to come over here and we're going to have this other intercept over here at -1, and then we would anticipate our 1 at 6 over on the right. If we look at the tables, we see that we still have those same intercepts. Wildly different y values everywhere else. We've got a function that's now growing as we go left to right in general, as opposed to decreasing, and we're getting much larger values in the y column here than we were getting from our original function. Key to note, still the same intercepts. Let's look one more time at our third graph that I've introduced. This one, I just took the second one and multiplied it by 5. Should still have the same end behavior, pointing up on the right and down on the left. But let's check to see if it also has the same intercepts. And fortunately for us, it does. Growth that's a little bit closer, almost symmetrical, thanks to the 5 and 4 relationship, almost symmetrical to the growth that we see, or the change that we see in the blue, the original graph that we started with. But we still see that positive end behavior, and again, we still see those same intercepts. And if we table it, we still see those same intercepts. 2, spitting out zeros across the line. 6, spitting out zeros across the line. Wildly different growth here, even compared to the other one that was positive and had the same end behavior. Significantly higher growth by the time you get to 10. Not important to our conversation. The important thing to our conversation was it did not matter the multiplication I put here. Those intercepts stayed the same. Thanks to this factored form, I maintained all of those intercepts. I kept them where they were. Nobody shifted left and right. Sure, there was different levels of growth everywhere else on the y-axis, but whatever growth that it had retreated back to the x-axis thanks to those factored forms. So if you're looking to write your own function, you're going to start the same way. You're going to start by identifying those key points. But those multiplications that you do are critical to make sure that you end up with 1, the correct end behavior, and 2, making sure that you end up with the correct intercept.